All right, guys, here's the second half of the review guide for the or for the test that's tomorrow. So, we're going to be doing in this review, we're going to be looking at our inverse tangent functions, our nautical bearings, and a couple of word problems and solving the triangle. If you're looking for graphing, you want to look out for Miss Allen's graphing seminar that will happen on another video. So, let's get down to it. Now, when we're looking at these trig inverse trig functions, we're going to be, if they are the same, like sine and inverse sine. Here's the great thing about this. Because they're the exact same, we could cancel out and our answer would be 1/2. The reason is because if we look at the inverse sine of 1/2, we go to where sine is 1/2. Well, that's pi over 6. Well, let's find the sine of pi over 6. If we looked at the sine of pi over 6, well, it's 1/2. And that's kind of like the process of how we're doing this today. So if they're the exact same, you're going to have inverse cosines. The answer is going to be the square root of 3 over 2. Then you're going to have the tangent and then a tangent inverse of the square root of 3. That will just be the square root of 3 because the way that we, again, just reminder on tangent is the sine over cosine. So if I'm asked to find the inverse tangent of the square root of 3, I'm looking for where if I divide the sine value by cosine, where that will be square root of 3. Here's a neat little trick. What's bigger? If you look at the sine value of the square root of 3 over 2 and divide that by 1/2, well, when you simplify this, you'll have the square root of 3 over 2 times 2 over 1. Well, that's going to be the square root of 3, so then that means this will be pi over 3. So for all factors of pi over 3, it's going to be the square root of 3. All factors of pi over 6 will be the square root of 3 over 3. And if you're looking at cotangents, the cotangent inverse, or the cotangent of pi over 3, all those values of the 3's will be pi over 3 over 3. And if you're looking at the cotangent of pi over 6, all those will be the square root of 3. All pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. Now, if you tuned out for this section, that's okay. It doesn't quite matter for what we're going to do moving on. So, looking at the inverse cosine of the square root of 2, what I'm going to do is I see the square root of 2. Reminder that cosine is all values that are above the top half. So it's this inverse cosine are all top half values. Those are the only ones that we're looking at. So these two, we're not checking out. We're not going to look at them. So we're going to go to where cosine is the square root of 2 over 2. Well, that's going to be a reminder that we're looking at cosine of theta and sine of theta. So cosine square root of 2 over 2, I see it's here. So that means the inverse cosine of the square root of 2 over 2 is going to be pi over 4. Now, that's only halfway there. Now we got to get the sine of pi over 4. And when we take the sine of pi over 4, I'm going to look at where pi over 4 is. The sine is this y value. That'll be the square root of 2 over 2. And it's just awesome that it worked out for us there. So if we're looking at another one, let's do tangent. Oh, what we noticed? They're the exact same. Cancel out, and it's just going to be the square root of 3. Here, now we have it where we're having an angle measure and then the inverse trig function. So we're going to take the sine of pi. Now sine is only the right side. So we're only looking at these right side values. That's sine and tangent. That'll be for both of us. These will be our right side. Now sine of pi, I'm going to be looking at, now in this case, because this is an inverse sine, this is only negated for the sine inverse and tangent inverse. I can take the sine of pi. So going to sine pi, that is going to be this 0 value. So now I'm looking for the tangent inverse of 0. So tangent inverse of 0 means where I'm looking for the spot where sine is equal to 0 and cosine is some number value. And so with cosine being some number value, it doesn't really matter, but in this case, it'll be more than likely this 1. So that would mean answer is 0, because if I look at the tangent inverse, which is this location, that will be answer of 0. Now, let's see. Oh, don't have one here, so this is just a unit. Here we go. Looking at the inverse cosine of square root of 3 over 2, if I'm doing the inverse cosine of the square root of 3 over 2, I'm going to look on my unit circle. Remember, inverse cosine, only this top half. So if we're only looking at this top half, then we're going to be looking at, let's see, here's the cosine of square root of 3 over 2. Well, that's positive here and here, but again, we're not checking out this side. So we're going to look at then this angle. So given this side length, we're going to take this angle, and that's going to be taking the sine of pi over 6. So one moment, I'll do something. You good? So with this, we had the sine of pi over 6. So I'm going to take this sine of pi over 6. And remember, sine is the y value. So I'm just going to look at the y value of pi over 6. Well, that's going to be 1/2. And that's going to be our answer. Now, just a reminder, if this was a negative pi over 6, I'm going to be going down pi over 6 to this location. And so this would just turn into a negative. So now let's look here. I got cosine of pi over 2. So the cosine of pi over 2 is this x value here. So I'm looking for the inverse tangent of 0. Well, I think we've done that before. Wasn't that here, right? So that answer is 0. I just want to, let's see, it's not on here, but I want to just kind of make one up. If we're looking at where the sine inverse of negative 1/2. If we're just looking at this and we want to take the just looking at the sine inverse of negative 1/2. We're going to find, okay, well, sine inverse of negative 1/2, just looking at the right side. These sides we don't look at. This right side here, I found my sine. And now it's telling me 11 pi over 6, but because of our range is from 0 to negative pi over 2. This, instead of pi over 6, 11 pi over 6 will be negative pi over 6. So our answer, if we're just taking the sine inverse of a negative 1/2, it's going to be negative pi over 6. So that'll conclude our unit circle part. Now this is going to be what we're looking at if we don't have a unit circle. So if we did not have a unit circle, I'm going to be drawing a triangle for this problem. Now, it doesn't matter the direction that you draw. Again, it does not matter. For me, it matters for me, but it won't matter for you. I'm going to draw this because this is a negative sign. That means it's going to be facing downwards, having that downward slope of sine. And so that means my hypotenuse, because sine is opposite over hypotenuse. Hypotenuse is 11. My opposite is 6. I'm going to make that a negative because of this negative is attached here. So with that, I'm going to take and try and find this adjacent side because tangent is opposite over adjacent. So I'm going to do 11 squared. It's going to be equal to negative 6 squared. And I'll just call this plus x squared. So 11 squared is going to be 121 equal to 36 plus x squared. Now that I've done that, I'm going to look at doing subtracting from 36. And that would give you 85 equals x squared, and x is going to be the square root of 85. Now, in this case, with this picture, I am going to have it where I draw it this way. I'm sorry for that. Because if I set it up at my origin point, then it would look something like this. So this is going to be here the square root of 85. And with that, I'm just going to take the square root of 85 as my adjacent side, and my top will be that negative 6. So I'm going to have the negative 6 over the square root 85. But again, we don't like radicals in the denominator, so we're going to multiply by the square root of 85 over the square root of 85 to get negative 6 square root of 85 over 85. And again, I'll just kind of go back and explain. Sorry, I am. As many of you are watching this, you're probably tired. I'm probably tired as well. We are looking at drawing the sign in the negative direction and the cosine in the positive direction when we drew this. So let's keep moving on. We have this last one here, and again, sorry, it's this negative. So let's draw our xy plane, and then from that we're going to extend our hypotenuse. Hypotenuse, remember, sine is opposite over hypotenuse. This is going to be 6, and then from here I'm going to do a negative 1. And just kind of going back, the reason why, if I drew this way, this would be in quadrant 3, but we know with inverses we're never in quadrant 3. We're never, ever, 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 ever in quadrant 3. So we want to stay in that quadrant 4 lane. So then I'm going to try and find this x value because I'm looking for cosine, which is adjacent over hypotenuse. So if I'm looking for that adjacent side, I'm going to do 6 squared. It's equal to negative 1 squared plus x squared. So that'll be 36 is equal to 1 plus x squared. So that'll be 35 is equal to x squared. Now I need to square root both sides, and that'll leave me with x is the square root of 35. Now that's not our answer. That just solves for this side. I'm going to take my adjacent side of square root of 35, divide that by my hypotenuse of 6, and that will be my answer. Now, when I'm doing this, this is 1 point. Here's your 2 points. Here's your 3 points. If you're on a quiz, and that's how our points is going to work. You get a point for drawing the picture right, a point for finding the value, and then a point for that. So that's it for our inverse functions. I think that's been about probably 10 minutes of that. So let's kind of move into nautical bearings. So nautical bearings is, let me see how much time we've been doing. I want to make sure that this video doesn't get too big, so when I put it on the internet, I guess you can't tell. So we'll just keep going, and then once we finish, we'll be done. Nautical bearings. Here's the tip. Always start with a north or south, then do your angle measure, and then either add an east or a west. Now, remember that we never eat soggy waffles. That helps us label our graph. So if we're never eating soggy waffles, if I'm looking for O to A, I'm going to go from O to A. Whenever we're doing our nautical bearings, we're always starting at our y-axis. So because we're always starting at our y-axis, we should never get that part wrong. We never look at your x-axis. Always start from the y, this vertical axis. So O to A, this is in the northwest quadrant, so I'm going to know that is north and west. And now I want to put my angle in the middle because this, when I verbalize it, I'm going to looking for this. That'll be 40 plus 23, which is going to be 63. This is going north 63 degrees west. So going north 63 degrees west. So if I'm going O to B, that'll be north 23 degrees west. So go north 23 degrees west. Now going O to C, I'm going to have this in a different color. O to C, I'm going north, and now I'm going east, and I'm going 13 degrees. So north, 13 degrees east. Now, let's look at going from O to D. If I'm doing O to D, I need to combine 13 and 52. And when I combine 13 and 52, I'm going to get 65 degrees. But remember, when I'm labeling, it's going to be north 65 degrees east. Now for O to E, this is just our origin point. It's saying that from our origin, we are going from the origin to E. So I'm just going to combine 17 and 31. When you add 17 and 31, that would be 48 degrees. So then this is going to be now going south 48 degrees east. Going from O to F, I'm looking, again, starting at your y-axis. Always start at the y-axis. Going south 17 degrees east. And we got two more. Final stretch. We got going from the y-axis from OG, because it's the OG problem. This is going to be south 34 degrees west. And O, we're having OH. So going from O to H, I'm going to take this and go all the way to H. Always, again, notice how all these start at the y-axis. We're never starting at the x-axis. Always start at the y-axis. So going from here, I'm going to add 20 and 34, so that would give me south 54 degrees west. So this is nautical bearings. This is our happy place, because this is where we should be getting good grades, getting those good check marks, those A pluses, and we can maybe even be super happy. So because we're super happy, we're going to go down. We got 3 more problems to look at. Push through. I know y'all are tired, but this one, for this problem, we're trying to find out this angle, or this side length x. In order to find out this side length x, what I'm going to do is I'm going to look first for the full length here, x sub 1, and subtract that from the length here of x sub 2. The reason I can't only get this is because this is not a right triangle. Because it's not a right triangle, we can't do that. So setting this up, I'm going to look at x sub 2. If I want to find out x sub 2 length, I need to be using tangent, because I have my opposite side and I'm looking for this adjacent side. So I'm going to take the tangent of 64 degrees, set that to equal to my opposite side divided by my adjacent side. Now what I'm going to do, I'm going to multiply both sides by x sub 2 to get my x sub 2 by itself on this side. So that'll be x sub 2 tangent 64 degrees. I'm going to set that equal to 300. Well, now I need to get rid of my tangent. So I'm going to divide both sides by the tangent of 64 degrees, which will give me x sub 2 is going to be equal to 300 over the tangent of 64 degrees. Now if I pull out my calculator here, let's see, yep, there it is. Uh-oh, it went away. Here it is. If I pull out my calculator, I'm going to clear, I think you can see my screen. Make sure in mode, you see how I'm in radian mode? I need to change that into degree mode. Once I'm in degree mode, I'm good. So then I can do 300 divided by the tangent of 64. When I hit enter, that'll give me the answer 146.3197. What I would like for you to do, just round to 2 decimal places. So we're just going to round that off to, what did it say? It said 146.32. 146.32. So we're just going to keep that there, because that solved only for x sub 2. Now let's solve for x sub 1. If I'm looking for x sub 1, I'm going to have it where now I'm looking at the big triangle. And from this big triangle, I'm going to have I'm going to have the tangent, I'm going to have the, oh no, too much going on at one time. All right, tangent of 34 degrees, because I'm looking at this angle here. From this angle, I'm looking at the opposite over my adjacent, and I'm going to set this to 300 over x sub 1. Now, rather than doing this two-step process, I'm just going to do a nice little quick switch with x sub 1, and that'll be 300 over tangent of 34 degrees. So looking at our calculator, we're going to take, gotta get all of that calculator. I'm going to take 300 divide by tangent of 34, and that'll be 444.77. So 444.77. Now what I'm going to do now is I'm going to take x sub 1, this full length, and subtract that from that length to get our x. So I'm going to do 444.77. I'm going to subtract that from 146.32. And when I calculate that, that should end me with a grand total of 298.45. All right, now I know you're excited because we are now entering the life of word problems. So, word problems, we're just going to be looking at 2 of them today. We're going to be looking at 23 and 21. So, I'm going to just start off with 21 first. So, it says Emily is walking around the neighborhood to get some exercise. She walks, 1 mile. So, that looks like some good information. Heading north 17 degrees west down Smith Road. Now, Smith Road doesn't matter. Then she turns due south. Due south, that's very important information. And heads 0.87 miles down Jones Road. She would like to return home. What direction should she head, and how far from home is she? Now, reading that problem, I'm underlining as I'm reading the important information. Now, if just a helpful hint, if it's looking for what direction and how far she's going, that means we need to find out the direction and how far. So to do this, we're going to kind of draw a little compass rose. And now I know that she's going north 17 degrees west. This is our little girl here. Have a nice little... There's our girl. She's happy because she's walking. She's doing math. So she's walking 17 degrees north of west. And how far did she go? 1 mile. So we know that this is going to be 1 mile long. And then after that mile, let me get rid of that right there. Okay. So after she's walked 1 mile, then she turns due south. So turning due south means she's going this way. And she goes this full length, it would be 0.87 miles. So that's 1 mile. This is 0.87. So if I'm just going to kind of turn this into a word problem, that's going to be 1. This will be 0.87. And this is going to be a right angle. Now, let me draw a better triangle. That triangle doesn't look too nice. So if I'm going to draw a better triangle, let's try one more time, because I know that we like good triangles. There we go. Okay, third time was the charm. So this is going to be a right triangle. This length is going to be 1. Here's going to be 0.87, and then I'm just going to label this as B. Now, what I'm looking for is what direction should she head, and how far away is home. So I need to find out this B, because this is her starting point. And if this is her starting point, she needs to go directly east. And when she goes directly east, she's going to see how far away she is. So we're going to do 0.87 squared plus B squared equal to 1 squared. This is our Pythagorean theorem. So 0.87 squared is going to be equal to 0.76. This is going to be a regular B squared. This is going to be equal to 1 squared is 1. I'm going to subtract 0.76 from both sides. Now give me B squared is equal to 0.24. When I square root both sides, B will finally equal 0.49. So you could say that she needs to walk 0.49 miles due east, or you could say She needs to walk at least 1/2 a mile due east if she's trying to get home. Um, Now, the last problem that we have, and this will conclude our video, is a kite flies at height of 30 feet when 65 feet is string out. Uh-oh, there's some good information. Those are some numbers, height of 30 feet and 65 string out. If the string is in a straight line, find the angle that it makes with the ground. So that means if the kite is flying at a height of 30 feet, so that's going to be 30 feet, and it's 65 degrees out, find the angle between the ground. Here's my ground. So that means the ground and the kite. So that's an angle of depression because we're assuming that the string is straight. We're going to have 65 feet, 30 feet. So I'm just going to, what's this? Oh, opposite over hypotenuse. So it looks like we're going to be using sine, one of our trig functions. So we're going to take the sine, I'm going to call this angle x, sine of x, to equal 30 over 65. So then to get x by itself, I'm going to take the inverse sine of both sides. So that'll give me x equals sine inverse of 30 over 65. Now, here's the dealio. If we're trying to find it to the nearest degree, the angle needs to be in degrees. So again, with this calculator, make sure we're in degree mode. We're going to take the sine inverse of 30 over 65. That should give us 27, we'll just call it 27.5. So that would be 27.5 degrees. And that will be our answer. So thank you so much for watching this video. Hope this is helpful to you. And if you need help, I will be available tomorrow morning, 7:15. See you then.